Radio chargers. Essential for keeping radios charged. But it's 2021, why can't they be USB-C like everything else? In this video, we'll show you how to do just that to this and a few other devices, and why it's not quite as simple as you might think. So XSS found this little board which promises to be quite useful. It connects to USB-C and negotiates 9 or 12 volts via power delivery. Let's just do a quick test to start with. We start with power bank. It's negotiated 12 volts with the power bank, and we got 12 volts at that end. Flip this little switch and it disconnects it, and then negotiates 9 volts again. But unfortunately, here's where things start to go wrong. 9 volts. Let's try a phone charger, also 9. We'll try this car power adapter. This one supports 12. So what gives? What's going on here? The power delivery standard you're likely to face is Power Delivery 2.0, which came out at the same time as the release of the USB-C connector. Thing was, Power Delivery 2.0 had one change over Power Delivery 1.0, and that was supporting 12 volts became optional. And you know what they say about optional parts of the standard. But I mean, the thing is, a lot of devices don't want to pull 12 volts. It's too much voltage to efficiently charge a phone, and it's not enough voltage to efficiently charge a laptop. The other thing is, this power delivery device will pretty much just attempt to ask nicely for the voltage it wants, but those are just connected to the USB-C power pins. We're only getting 5 volts. We get what we get. So naturally, simply setting this to 12 volts and putting it into the radio charger is going to result in a lot of disappointment. So how exactly do we get around this problem? Well, we need another board, which is a buck boost converter. We can give it the voltage that we get on the input, and it will give us the voltage we want on the output. Okay, so we're feeding 13.82 volts into this thing, and we're getting 22.5 volts out. So now we take a screwdriver, 21, 20, half a little, nearly. That's set at 12 volts. Get 12 volts out. We can feed in 9 volts and we get more or less 12 out. 7, 6, 5, and get 12 out. We can feed in 18 volts and still get 12 out. So this is like a Swiss Army knife of voltage conversion here. Time to avoid some warranty. Vacuum desoldering stations are amazing, and if you do this sort of thing often, buy one. Yeah, a lot of empty space in here. That'd fit alright in there, but if I just shifted that capacitor, we'd be good. At this point, it's just a matter of finding somewhere to stuff the 2 additional PCBs into the case of the charger, which requires a bit of modifying of the charger plastic. And would you look at that, it even works. But what if we connect it to a normal 5V USB port? It still works. How good's that? Now the UV5R is one step more annoying. The plug pack isn't even 12 volts. It's 10.5, which is annoyingly uncommon, and if you plug 12 volts into it, it'll burn out. We thought it might be okay with 9 volts, but it's not. So we're going to rewire the DC socket to be before the voltage converter, so now it can take any plug pack and USB-C. As you can see, it now even works on 5 volts. But what if you don't want to modify your radio charger? Well, the very first thing we actually did was we went on eBay and bought this, which seems like it's the right kind of thing, but again, it only negotiates power delivery, and it's got the same 12 volt problem. The other problem that it has, if you have a USB-C adapter with a fixed cable, you simply can't use it. So we'll have to make our own again. USB-C, buck boost to DC barrel jack. Actually, hell, why not make it 2? Why not indeed. Cover this in heat shrink, fold that back on itself like that. We got 9 as expected, and we're getting on the output 23. Now naturally we want to wind that down a little. 12 volts. And there we go. That's not quite enough. That'll do that one though. We'll use some non-glue lined heat shrink on this, then hot glue it to that. So that's the version that doesn't require modifying your radio charger. This is the battery pack we use for portable radio operation. It's made up of 3 Turnigy lithium iron phosphate batteries in parallel, giving us just over 25 amp hours. It's charged using this ISDT T6 charger, which needs a DC power supply with a few watts. But what if we could just borrow a laptop brick for it? So this one's a little different to the other ones. Instead of giving you 9 or 12, it gives you 15 or 20. So now I'm going to put an XT60 on that in order to have that plug straight into the charger. That's pretty much perfect right there. 20 volts, check. 96 watts, so we'll go 90. Connect the balance cable. So pulling 20 volts at 90 watts. Oh. 90 was a bit too much to ask for, but limited to 80 it happily gave the battery a full charge. For strain relief on the connector, I'm going to epoxy the end, then put the whole lot in glue-lined heat shrink. This ensures mechanical stability given that it's sticking out of the side of the charger by its plug. A quick test shows that it still works. This is a mid-2014 MacBook Pro, which uses the MagSafe power connector. Can we make this able to be charged off USB-C? So what we're going to need is again one of these with the 15 and 20 volt option, and we're going to need a MagSafe cable. Now, Apple won't exactly go and sell you one of these things, but if you've owned that machine since mid-2014, you probably have a dead MagSafe adapter lying around. Now I'm going to cut this off at a little more adapter-y length, and then the cable is actually coaxial. So we've got our outer here, there's a Kevlar pull string for strength, and then we've got our inner wiring. So if we test between you'll see there's 5 pins here, so the outer 2 are ground, the inner 2 are power, so it doesn't matter which way you put it round, and the middle one is a 1-wire sense wire, which uses 1-wire protocol to the chip in the plug that allows the host to control the green/orange LED here to say whether it's charging or not, and lets it read the wattage of the adapter out of that chip. So this one is from an 85 watt adapter, so it will try and pull 85 watts out. If your USB-C source can't handle that, you will have to pull a head from a 65 watt adapter. So we're going to use this in 20 volt mode. While the MagSafe 2 adapters were typically all 18.5 or 19 volts, there is a MagSafe 1 to 2 adapter, and the early MagSafe 1 adapters were that shipped with 15-inch MacBook Pro were 20 volts. It should be safe to run 20 volts in. So, 20.5 volts, a little on the high side. We have 20.5 volts between that and that. So now, something you may ask is, how come, if you get a bit of something metal on this connector on a normal MagSafe power adapter, how come that's never really been a problem? Well, the thing is, we're actually bypassing one of the safety features here. Normally the adapter measures that it hasn't got a short circuit on it, and then waits for about a second between the connection being established with the computer and actually turning the power on. That's why you see the little delay before it lights up, because it's checking that it's not short-circuited and waiting for it to be securely attached. So we've kind of bypassed that safety feature here, so just be aware of that and be careful when you're attaching it. So now, there we go. So you'll see here it's recognized as an 85 watt adapter and it's charging. So now I'm just going to cover hot melt glue to protect the connections. I'm actually out of it in black, so we're going to use red. And there we go, another cursed adapter. And that's how to make everything charge off USB-C. Until next time, like, comment and subscribe.